Ionic equilibrium. Under that, we have to study Oswald's dilution law, common ion effect, solubility and solubility product, acids and bases, ionic product of water, pH scale, pK value, buffer solutions, buffer action, and buffer capacity. According to Oswald's dilution law, for dilute solutions of any electrolyte, you can write alpha equal to square root of K by C. And concentration is inversely proportional to volume. Therefore, we can write alpha equal to square root of K into V. We can derive this formula at any moment. Common ion effect means if you have acetic acid, say CH3COOH, one of weak acid, it dissociates partially as CH3COO minus and H plus. If you treat it with very strong base NaOH, you can get salt of this acid, that is sodium acetate CH3COONa, and when it dissolves in water, you can get CH3COO minus and Na plus. Now these CH3COO minus ions are common. CH3COO minus ion should combine either with Na plus or with H plus. If it combines with Na plus, you must get back this sodium acetate. If it combines with H plus, means you must get back this acetic acid. And if you consider H plus and Na plus, this is somewhat bulky. And this is very strong salt, means dissociates completely, ionizes completely. It means that this acetate ion cannot combine with Na plus again in this reaction medium under the given condition, and hence it should combine with H plus. You must get back this acetic acid. In other words, there is a suppression of degree of dissociation of acetic acid. So dissociation will be, rate of dissociation is decreased here. Or in other word, here H plus ion concentration goes on decreases. Therefore, acidity decreases, pH value increases. So suppression of degree of dissociation of a weak electrolyte by addition of a salt containing a common ion, that is called as common ion effect. One of the important concept. Another one, that is ionic product. Ionic means always with respect to water. So H2O, it decomposed as H plus and OH minus. So we can write equilibrium constant K, that is equal to molar concentration of H plus into OH minus divided by molar concentration of water. But molar concentration of water always said to be 1. So you can write it as Kw. So Kw means ionic product of water, that is equal to the product of molar concentration of H plus ions and OH minus ions. Next one is solubility product. Suppose we have one salt, say barium sulfate. It is a strong salt, means dissociates completely. I can write it as Ba2 plus and SO42 minus. By the concept of common ion, you can make it precipitate, means you can add sulfuric acid, it gets precipitate. Now, I can write equilibrium constant K here, that is equal to molar concentration of barium ion into molar concentration of sulfate ions, and barium sulfate is present at denominator, you can shift it to left side. Now, this is nothing but K solubility. So K solubility means it is the product of molar concentration of a cation and anion. Means there is a metal ion and non-metal ion. Ionic product of water means the product of molar concentration of strictly H plus and OH minus. Solubility means a metal ion and non-metal ion. We have different types of electrolytes. Electrolytes of type AB, means cation to anion ratio should be 1:1. Example, AgCl, AgI, NaCl, NaI, etc. You can give number of examples. Under such case, you can find out solubility. The notation for solubility is always S, S equal to square root of K into Sp. Similarly, for the salts of type AB2 or A2B means 1:2 or 2:1 type. For example, PbCl2, CaF2, CaCl2, etc. You can find out solubility by using the formula cube root of K solubility divided by 4. Similarly, for the salts of type AB3, the example, well-known example, aluminium chloride AlCl3 or FeOH thrice, etc. Under such a case, solubility S is equal to fourth root of solubility product divided by 27.